In this video, we're going to take a look at volume of prisms and cylinders. So a prism is a polyhedron with two congruent faces called bases that lie in parallel planes. So again, our bases would be this guy and this guy. There's two of them. There's always two congruent bases. And let's see. This one's a little trickier. It's the front and the back on this trapezoidal prism, and we have a hexagon on top and bottom on this hexagonal prism. So the volume is just the area of the base, which I've highlighted in each of these, times the height of the figure. So the height would be this guy. And let's see, we're going to actually have to do some math on this one because it's a, this is your height. And then the height here. All right, so let's take a look at an example. So our base, and I'm always just going to highlight or shade in the bases, top and bottom. We need to find the area of these triangles. And let's see. I don't have the height on the triangle because, see, this is the perpendicular. So on the triangle is 1/2 the base times the height. And so this is 1/2, well 5, but I don't know the height. The height is this guy. And so I'll have to do a little bit of Pythagorean theorem. Here's your right angle, so we know that the C is the 13. So 5 squared plus, I'll just say h squared is equal to 13 squared. And h squared is equal to, I believe this is, what, 169 minus 25. And h is going to be 144, so h is equal to, h squared, so h is equal to 12. So if I plug it into my formula, 1/2 times 5 times 12 is going to give me 30. So the area of the base is 30. I'll just say area of the base. And then my height is the 7. This is my height. Okay, so now for our volume is going to be the area of the base times the height. And so when I multiply those two, it's 210, and volume is units cubed. So we're always going to have a little 3 right there. All right, in the next figure, we have a regular hexagonal prism. Okay, so, shoot, we did this back in our other unit, and we know that the area of one of these angles is 120. So if I draw in my apothem, this is the way we find the area of a hexagon. Area is 1/2 the apothem times the perimeter. This angle here is going to be the 60, so I'm going to draw this triangle bigger because that's just too tiny. 60, and we know this guy is 30. Okay, so if each side length is 16, and we have 6, 16 times 6 is going to be 96. That's my perimeter. The apothem is found, let's see, I need 1/2 of that, so this piece right here is going to be 8. And this is a 30, 60, 90 triangle, x root 3 to x. 8 happens to be across from the 30, so across from the 60, I'm going to zoom in here so y'all can see this. Across from the 60, that's my apothem. And so that is going to be 8 roots 3. Okay, is that all right, everybody? 8 roots 3. That's the apothem. That's what I need for the area of this hexagon. All right, so anyway, I have my area is 1/2 the apothem times the perimeter. And when we plug that into our calculator, 8 root 3 times 96, that is going to be 665.108. And this is round to the nearest hundredth, so that's 2 decimal places, so 665.11. Okay, so this is the area of the base. Okay, so then for volume, it's the area of the base times the height. And the height is this guy right here. This is your height. So times 20, and that's going to be a big number. 13,302.2, and this is feet cubed. In the next example, this is the one that always stumps me a little bit. These are my bases, these trapezoids. Okay, in order to find the height, though, I need to find this distance here, the vertical, perpendicular to the flat surface here. So anyway, it says a right prism with a base that is an isosceles trapezoid with bases 8 and 16 and legs 5. So this is 8. That means this piece here is 8. Legs are 5. And that means that this little piece here and this little piece are both 4, because this what is this called? A base is 16. So 8 and 4 and 4 is 16, and then this guy is 8. So anyway, I need to try to find this guy. So I'm going to have to do some Pythagorean theorem. 4 squared plus x squared is equal to 5 squared. Hey, we should know that. That's a 3, 4, 5. X is going to be 3. That's one of our Pythagorean triples. And so you know what? I'll say h is 3. That's the height. Okay, so then the area of a trapezoid, so because we need the area of the base, that is 1/2 base 1 plus base 2 times the height. Okay, so the two bases are 8 and 16, and the height we just calculated as 3. All right, so let's see, 24, half of that is 12 times 3 is 36. So the area of the base is 36. My volume is base times height, and 36 times, oh, wow, wrong height. And it's okay, we can make mistakes. This is your height of your prism. It's deceiving here because your base is actually facing us. If you were to stand this up on its side, this would be your height. And it tells you that the height is 15. All right, so 36 times 15, and that's 540. And do I have units? No, I have no units, so I'm just going to say units cubed. In number 4, it says the volume of a rectangular prism, volume is 504 cubic centimeters, so that's centimeters cubed. That's how you write cubic centimeters. The area of the base is 56 square centimeters, because that's area. What is the height? Well, volume is just base times height. Oops, what am I doing? Setting that up totally wrong. Volume is base times height, and we just need to divide both sides by 56, and the height is equal to 504 divided by 56, and that's 9 centimeters. All right, take a look at cylinders, a solid with congruent circular bases that lie in parallel planes. So my bases, there they are. Here's my bases. Okay, so the volume is just, again, base times height. And so, of course, this is a circle, the circle base. So this is going to be pi r squared times height. Let's take a look at an example, and it says leave it in terms of pi. So my radius is half of the diameter, right? So my radius here is 12. Volume, pi times the radius squared times the height. And so, all right, and so when we clean this up, let's see, I just need to do 12 squared times 30, and it's going to be 4320 pi, and this is inches cubed. All right, one last example. It says using the cylinder above, if the height is tripled. So if my height, let's see, my height is 30, and if I triple that, that's going to give me 90. So my height is 90. What is the ratio of the volume of the new cylinder to the volume of the cylinder above? Okay, so we're going to assume that the radius is the same. So volume is pi times 12 squared times the height. Let's see what this is. So 90 times 12 squared, and that is going to give us 12,960 pi inches cubed. Okay, so we want the ratio. So we're going to take this new volume divided by the old volume. Okay, so we can see that the pi's cancel, and 12,960 divided by 4320 It is 3 times. And if we just think about that, that makes sense. Because if I were to have the same figure, but just triple the height, wouldn't it have 3 times the volume?